Hi friends, welcome to the Unit 6, Day 1A video. For these first videos in Unit 6, they're Day 1A, Day 1B, and Day 1C. They all revolve around simplifying radical expressions. Before we go in, we want to talk about perfect squares. Perfect square is just a number when it's multiplied by itself. You're going to see that we do this at the beginning of each of the sections. This is something that is helpful to have memorized at some point. To get that in your calculator, you just take that number times itself. So the perfect square for 1 times 1 is 1. 2 times 2 is 4, and so on. So remember, just to do that in your calculator, you just take that number times itself. So 3 times 3. Calculators also have a squared key. It's usually this key here where it says, that has a little x and then a squared. So you can do that also, and it gives you what the number is. So there's 9, 16. I used to have these memorized when we did this in person. I don't. So let's see how far I can get. 36, 49 for 7, 64 for 8, 81, 100. Now it starts to get a little dicey. All right, 121, 144, 169, 14, 225. Yeah, I'm not feeling confident with these. All right, let's just grab my calculator. 196, 15. Is it 225? It is. Okay, 16 squared, 256. 17 squared is 289. Again, I'm just using my calculator. 18 squared, 324. 19 squared, 361. And then 20 squared is 400. It's helpful to know those as we get into the radicals so that you can see how we actually simplify them. Every radical expression has 3 parts. So I wrote in the index. The index tells you, this is also called the root. So that's another name for it, a root. This part here is called the radicand. That's the part that's underneath the radical symbol. So this is the radical symbol. So when you say a radical, you're actually talking about this right here. A radical expression is just an expression that contains a radical. So here's an example: 3 radical 2, radical of x plus 4, 7 times the radical x minus 8. So those are all some examples that contain a radical. When we read radicals, we read them. So this is 5 times the square root of 117. So that's how that works. This says watch the simplifying square roots video from Khan Academy. That's a good way if you wanted to get some additional practice. I'm actually going to show you how to do this with here as we go through. So to simplify square roots, the best way to operate through this is to, excuse me, is to actually see what's the largest perfect square. Because these are square roots, we're going to be just working with perfect squares. What's the largest perfect square that you can take out of 117? So going back to our list from up top, 117, I can't use 121 because 121 doesn't go into 117 evenly. 100 doesn't go into 117 evenly. What do I mean by that? If I take 117 divided by 100, I get a decimal. Or a fraction or a remainder. So that's what we're doing when we say it goes into evenly. So now I just keep going down the list until I find one that does work. So now I did 81. So the next thing I do, 117 divided by 64. That one doesn't work. 117 divided by 49. That one doesn't work. 117 divided by 36. That one doesn't work, though I'm getting closer. 117 divided by 25, that one doesn't work. 117 divided by 16, that one doesn't work. 117 divided by 9, that one does work, and it gives me 13. So that gives me my largest perfect square. So what I do when I split up my factor trees, so this is going to be 5. I'm just looking at this part here when I do my simplification. So 117, I make my factor trees, and the way I make them is I put the perfect square on the right and the remainder on the left. So I have 9 and 13. So then 9 is a perfect square So what we do is we split this up. We're going to take 117. So we have 5 times, well, what are the two parts that make up 117? Well, the two parts that make up 117 is 9, so we're going to take the square root of 9 times the square root of 13. In products under radicals, you can actually split them up. So they're both under their own radical. So 5 times square root of 9 times the square root of 13. And we can simplify this. Do you actually know what the square root of 9 is? We've done that previously. The square root of 9 is 3. So we have 5 times 3 times the square root of 13. Now to simplify this, 5 times 3 is 15. So we have 15 square root of 13. And then I'm going to box my final answer here. Now, the goal is, as you're going through and doing these, is that you can see them sooner than just going through and kind of checking all of the ones that are less than that. With 26, it may be a little bit obvious which way to go. But if not, again, just go through all the ones that are less than. So 25 doesn't work. So 26 divided by 16, that one doesn't work. 26 divided by 9, that one doesn't work. 26 divided by 4, oh, close. 26 divided by 1, what did I miss? 25, 16, 9, 4, 1. So then we're just left with this one. So this tells me that the only two numbers that go into 26 are going to be prime numbers. And in fact, 2 and 13 are the only ones that go into 26. Now 4 was close, but 4 gave us a remainder, so we got to be careful about that. So this one, because I can't pull out a perfect square, it's actually just kept as 3 times the square root of 26. You can't simplify it any farther, so we just leave it like that. That's how that one works. So now for the examples at the bottom, circle your final answer. It's actually really important that you communicate that to your instructor when you get finished. That way your instructor knows, hey, I'm done with this problem. So for 50, again, just 50 all by itself, what we're going to do is we're looking for the perfect square that goes into 50, the largest perfect square. I know that 25 is the largest perfect square that goes into 50. And then I have 2 as my leftovers, so that when I split this up, I'm going to have the square root of 25 times 2. Now remember, we can split this up into its two parts. That's going to give us the square root of 25 times the square root of 2. The square root of 25 is 5, so that gives me 5 radical 2. And then there's my final answer. With 80, let's see. Ooh, I'm going to guess that it's 4, but I don't think it's actually 4. I think it's a larger one. So I'm going to grab my calculator just to double check and make sure. So I'm going to check this. So I have 80. So let's see. I can check divided by 64. Nope. 80 divided by 36. Nope. 80 divided by, oop, I missed 49. 49. Nope. 80 divided by 25. Nope. 80 divided by 16. Yep, all right, that's the one. That was the one I was thinking on too. So, good thing I double checked. So, again, grabbing my factor trees, 80. So 16 and 5. 16 is a perfect square. I'm stopping at these perfect squares because, and this is different than the factor trees you made back in elementary school, because they're a perfect square. They're a pair. They will always have the next two numbers below them that make up them, so I can always pull out a perfect square. This way is actually shorter than the ways that you learned probably in a previous class. And this does work all the time because we're doing square roots. If we were looking for a different number, like a cubed root, then we need to look at perfect cubes instead. So then square root of 16 times the square root of 5. Square root of 16 is 4. So the square root of 80 is really 4 times the square root of 5. 18, largest perfect square that comes out of 18 is 9. Oh, I forgot to circle that answer. Is 9. So here we're going to have square root of 18 is the same as, I'm on a weird part of the table. There we go. Square root of 9 times 2. Square root of 9 times square root of 2. So that gives me 3 times the square root of 2. And then we circle it. we've done a lot of examples so far. Go through this, see as far as you can get, like pause the video, see as far as you can get without me going through them right now, and then come back to see, like, you know, how far you got. And if you're struggling with it, that's a good thing to do. So I'm going to continue on through. But I'm actually going to stop the video because I just saw the time. I'm going to stop the video and I'm going to do this one in the next video. But see how far you can get before you watch the next video. Bye, friends.